Okay, for this video, we'll be going through G3 Science Dynamics. Okay, actually this is a quick recap because I think last lesson we actually did Newton's first, second and third law. Okay, so this is just a recap. So I'll be going through Newton's first law first. Okay, Newton's first law. Okay, so Newton's first law is actually the law of no resultant force. Okay, no resultant force. Okay, or balance forces, or F net is 0. Okay, so this is Newton's first law. Just take note that there's no resultant force, or the forces are all balanced, or the F net is equals to 0. They all mean the same thing. Okay, so when we say that there is no resultant force, it doesn't mean that there is no force acting on it. It just means that the forces are all cancelling each other out, such that there is no net force, no resultant force, or F net is 0. So what is this effect on the motion of the object? So there are two cases. It depends on whether the object is initially at rest or already moving. So we touch on the first case first. If the object is at rest, and if there's no resultant force, it will remain at rest. Example, I place my water bottle on the table, it will remain at rest, okay, until somebody pushes it, right? And that push is actually a resultant force. Okay, so this is the first case. Or if the object is already moving, or when it's already in motion, it will continue in its state of motion with constant speed or constant velocity. Okay, and actually in our kinematics chapter, we learned that constant velocity means your acceleration is 0. Now this is important because later on we'll be using this concept in the formula. Okay, so just remember Newton's first law, there's no resultant force. What will happen to the motion? If the object is at rest, meaning not moving or stationary, it will remain at rest. Okay, but however, if the object is in motion, it will continue in its same state of motion with constant speed or constant velocity. Okay, so there are two cases under Newton's first law. You have to see whether the object is really moving or if it's stationary. Okay, so some example here. Look at this body. I have two Newton forces acting on it. Okay, are there any forces acting on the body? Yes, in fact, we have two of these 2 Newton forces. But because they are acting in the opposite direction, they will cancel each other out, and therefore, there is no resultant force. Okay, then if we look at this example next, we have 4 Newton pushing to the right, 2 Newton pushing to the left. Is there any forces acting on the body? Yes, we have 2 forces there. Any resultant force? Yes, we always take the larger force, subtract the smaller force, and it is 2 Newton. So the resultant force, it is using a double arrow, and then we indicate the value of the resultant force on it. Okay, I already explained in class that the resultant force arrow, which is the double arrow, should not touch the object. Okay, so this is a case whereby there is resultant force, right? This is a no resultant force. This is a case whereby it has resultant force. Okay, so what will happen to this object? If it is already moving, then it will move with constant velocity. But if it is stationary, it will just remain there, even though there are 2 of these 2 forces pushing on it. Okay, so this is Newton's first law. Now, Newton's second law is very different from Newton's first law. The object can only obey either Newton's first law or Newton's second law. What is Newton's second law? If the first law is that there is no resultant force, Newton's second law simply means that there is resultant force. There is. Okay, there is a resultant force. Okay, so you need to know this formula. Resultant force equals to mass times acceleration. Okay, and take note, all this must be in SI unit. So example, I told you all in class already, 700 grams, it will then become 0.7 kg. Only then can you substitute into the formula. So this formula is for finding the resultant force and not for finding any other forces. Okay, it's just to find the resultant force. Let's look at some examples here. Okay, Okay, so in this case one, we have a stationary object. That means it is at rest. Now it is pushed by many forces. I have a 2n here, 2n here. So because they are in opposite direction, they'll cancel each other out. I have a 2n here and a 2n here, so they'll cancel each other out. 2n here and 2n here, cancel. 2n here, 2n here, opposite direction, so they'll cancel out. So are there any forces acting on this 1 kg block? There are in fact 8 of these forces. But is there any resultant force? No resultant force. And we give you the case whereby it is stationary, it is at rest. That means it is not moving. If it's not moving, the speed is 0. 0 speed means 0 acceleration. Any forces acting on the object? Yes. But what about the resultant force? It is 0. 0 Newton, right? So you can try to use Newton's second law, which is F net or F resultant equals to ma. The mass is 1 kg. There is no F net, therefore the acceleration is 0. Or if the acceleration is 0, that means F net is 0. Okay, if we look at this formula, F net equals to ma. Mass cannot be 0, right? But if the F net is 0, therefore acceleration must be 0. Vice versa, if the acceleration is 0, that means F net is 0. This is a very simple relationship. Okay, and since the object is already at rest, not moving, therefore the object will remain at rest. Okay, how about we look at another case, case 2. It is moving with constant speed. Constant speed means it's moving, same speed, therefore 0 acceleration, right? So are there any forces acting on the object? Yes, there are. And because you see from this diagram that the resultant force is 0, so therefore 0 Newton. Then we use Newton's second law, which is this formula, F net equals to ma. So again, the mass is 1 kg. Make sure it's in SI unit. Okay, F net is 0. That means your acceleration is 0. Okay, but since the object was really moving at constant speed, it can be any speed, 20 meter per second, 10 meter per second, 2.5 meter per second. It will then continue to move with constant speed. So this is a case whereby if there is no F net, okay, if F net is equals to 0, then it will either remain stationary or move with constant speed. Okay, then let's look at another example. Okay, basically this looks similar, just that I am now missing my 2 Newton force over here, right? So this and this will cancel because they are in opposite direction and they have the same magnitude. This and this will cancel, this and this will cancel, but this 2 Newton is not being cancelled off. So this makes it the resultant force in this direction, 2 Newton. Okay, so how do we find the acceleration? Now, because this is the only force left, this is the resultant force, therefore my F net equals to ma. My F net is 2 Newton, right? My mass is 1 kg. My acceleration will then be 2 meter per second square. Okay, so this is first law and second law. Okay, we'll cover third law later. Okay, now I need you all to try these examples here. Okay, A1. A car moves along a level road. The following shows all the horizontal forces acting on the car. Okay, which statement is correct? So, what are the forces that are acting on this car? By the way, this is, if I were to not draw a car, I just replace it with a box. I have 2000 Newton. Okay, and I have 800 Newton air resistance because it's acting in the opposite direction, and friction is also 500 Newton. Okay, this is actually called a free body diagram. It shows all the forces acting on this object, free body diagram. All right, so we have 2000 to the right, 800 to the left, 500 to the left. So what is the resultant force? We take F net equals to, we take the bigger one, which is 2000, subtract 800 because it's in opposite direction, and we also subtract the 500 as well. So we'll get a value of 700 newtons. So this is my F net, meaning to say I can replace this diagram with, let's say, the car. I can just draw my resultant force of 700 Newton. Okay, and this is what you must be able to do. Okay, you have to arrive at the resultant force. That means you replace all the forces acting on the object, only showing the resultant force. So now there is 700 Newton of resultant force. So is it following Newton's first law or second law? It is Newton's second law. What does Newton's second law mean? It means that whenever there's F net, right, then there will be acceleration. So which one is the answer? D. It is speeding up. That means it is accelerating. Okay. So you have to determine what's the resultant force if there is any. So if there's no resultant force, it's law 1. So the object will either remain stationary or move with constant velocity. But if there's resultant force, like in this question, 700 newtons, that means the object is going to be accelerating. And with this formula, and if I know the mass, I'll be able to calculate the value of acceleration. Okay? Okay, A2, which of following shows a non-zero resultant force acting on the ball? That means this is following Newton's second law. Okay? So let's look at A. The ball is moving at constant speed. So whenever you see constant speed, you must be very happy because constant speed means acceleration is 0. And if acceleration is 0, that means your F net is 0. Why? Because F net equals to ma. If your acceleration is 0, that means your F net is going to be 0. But the question is asking for non-zero resultant force. So therefore, this is not correct. This is actually obeying first law. Okay, option B, a ball resting. So if the ball rests, that means it is stationary. If it's stationary, it is not moving. That means your velocity is 0. And therefore, your acceleration is 0. That means your F net is equals to 0. So you must be thinking in this way. Okay, so you first think about stationary. What does it make you think of? Velocity is 0. That means your acceleration is 0, and then your F net is equals to 0. That means there is no resultant force. But again, the question is asking for non-zero. So this is not correct. Okay, so now we have a free falling ball that has just been released. What is the meaning of free falling? Free falling means no air resistance. Okay, basically it is just the weight acting on it. The weight. And therefore, this weight will then be our F net. Okay? And if there is this value of weight and there's no air resistance to counteract the downward motion, so our weight will just be the F net, and therefore, there will be a resultant force. So answer is C. Now, how about a ball floating on water? Floating means not moving, right? It's not sinking, it's not rising, it's not moving. So not moving means stationary. So again, velocity is 0, acceleration is 0. That means the F net is 0. So are there any forces acting on this ball? Actually, there are. There's the weight, right? Which is actually the earth pulling the ball down. But because the ball is suspended in water, the water is also pushing the ball up. And this upward pushing force is equal but opposite to the weight. Therefore, there is no F net. Okay, so therefore A2 answer is C. Let's try A3. Okay, A3 is actually covering Newton's third law. What is Newton's third law? Okay, Newton's third law simply means there must be two bodies, two different bodies, A and B. Okay, so F, A, B means the force of A on B. And then we have FBA, which is the force of B on A. Okay? And FAB and FBA, they must be equal but opposite in direction. Okay? This is very important. They must be equal but opposite in direction. So a large plastic ball is dropped vertically downwards from the top of a tall building. So this is a plastic ball. The weight of the ball this is the weight of the ball, is one of the two forces that form an action-reaction pair. Whenever you see action-reaction pair, it refers to Newton's third law. Okay, so now the weight is one of the force. Okay, it's a force acting on the ball. But what causes this weight? Okay, it's actually from Earth pull ball down. Okay, so maybe I have Earth here. It is pulling the ball down. But now I must look for its action-reaction pair. I must look for its second body. That means I cannot be talking about the ball already. I must be talking about the other body, which is actually Earth, because the Earth is pulling ball down. So the other pair will be the ball pulling Earth up. Okay, Earth pull ball down, ball pull Earth up. Right, we are talking about different body. In the red color, we are saying Earth is forcing the ball, or exerting a force on ball. What's the direction? It's downwards. Okay, the action-reaction pair will be the ball, which is the other body, is actually pulling Earth up. Okay, so this is how we describe the other pair, and they must be equal and opposite in direction. Okay, now let's look at success criteria B. Identify forces acting on the body and draw free body diagram. So just now I already talked about free body diagram. It shows all the forces acting on the body. Okay, so a free body diagram uses arrows to represent the forces acting on individual objects. So you cannot be drawing free body diagram that consists of two objects. It must be one object, one free body diagram. If I want to talk about the other object, it must have its own free body diagram. So let's look at this aeroplane. Okay, what are the forces acting on it? We have the thrust, which is by the engine, so it pushes the plane forward. And as the plane flies in air, there is a drag force due to air. Okay, so the drag is due to air resistance. The thrust is due to the forward force of the produced by the engine. Then, because the plane is flying, there is weight, which is actually the force of gravitational attraction of the Earth pulling the plane down. Okay, there's also a lift force. That's why the airplanes can fly up. Okay, so if I have balance forces, if the drag is equals to the thrust and the lift is equals to the weight, why all these pairs? Because the drag and thrust is the horizontal forces, right? And if they are equal but they are in opposite direction, they'll cancel each other out. The lift and weight, they are the vertical forces, right? Lift is going up, weight is acting downwards, so they are the vertical forces, and if they are equal but opposite in direction, the plane will move horizontally with constant velocity, because F net in either up or down is 0. Okay, then how about if we have unbalanced forces? Let's say the lift is equals to the weight, but now the thrust is greater than the drag. So there will be a resultant force. There will be a resultant force in the direction to the right. So if then there will be F net. If there's F net, then there is acceleration. Therefore, the plane will accelerate forward. Okay, so this is free body diagram. It shows all the forces acting on an object and not the forces acting by the object. Okay. Okay, then this is Newton's second law. F net equals to ma. Just take note that everything is in SI unit. Okay, let's solve C1. An object is moving on a smooth surface. Why do we talk about smooth surface? Smooth means no friction. There is no friction. Okay, that means if it's moving to the right, then there's no friction that acts to the left. So maybe I do a sketch. This is the object. So it is moving on a smooth surface under a force F1. So maybe I call this F1. Okay, so in this case, in the horizontal direction, is there any F net? Yes. Okay, so in the first case, in this case, F1 is actually the F net, because the question says that it is a smooth surface, so there is no force to the left to oppose F1. So F1 is straight away Fnet. So what is the motion of this object? The motion is that it will accelerate to the right. Okay, so this is what I gather from the first statement. Now, after a certain time, another force of the same magnitude F2 is exerted on the object in the opposite direction. Okay, maybe over here now I use red color. In the opposite direction, same magnitude. Okay, so if I were to redraw, initially I have F1, right? But now, suddenly, there is F2. And I draw my arrows of equal length to show that they are equal in magnitude. Okay, but I draw them in opposite directions because this is what the question specifies. So then, what happens when this F2 is added? When F2 is added, it is equal and opposite to F1. Therefore, my resultant force is 0. Okay, so this is different from the top part. That's why it's called dynamics. The things will change. So now if my Fnet is 0, what do you think of? That means the acceleration is 0, right? So is the object already moving? Yes, already moving. So if it's already moving, therefore, Newton's first law states that it will move with constant velocity. Okay, before that, you compare, it was moving with a certain acceleration. That means the velocity will keep on increasing. But now throwing in F2 in the opposite direction, it results in the resultant force to be 0 and the acceleration to be 0. That means it will follow Newton's first law. And since it was already moving, it will move with constant velocity. So answer is A. Okay? Now, which of the following is not possible when the resultant force acting on the body is 0? So they are saying that now Fnet is 0. So what do you think of when Fnet is 0? The body will either remain at rest or move with constant velocity. Okay? So, A is possible, right? The body continues to move along a straight line with constant speed. So this is possible. Okay, but they are looking for not possible. So this is true lah. A is true. The body remains stationary. It is true. The body moves along a circular path with constant speed. This is very tricky. Because although the magnitude is the same, constant speed, constant magnitude, but it is constantly changing direction in a circular path. That means there's going to be acceleration. Okay, there's going to be acceleration. That means there's going to be Fnet. But now they are saying that when the Fnet is 0, so it contradicts this situation whereby there is Fnet. So this is not possible. So C is the correct answer. Okay, let's look at D. A body is falling through freely through the air at terminal velocity. Terminal velocity means maximum velocity. Maximum velocity or maximum constant velocity. So what do you think of? Maximum constant velocity, your acceleration must be 0, right? Because it is constant velocity. If acceleration is 0, that means your Fnet is 0. Okay, but now they are saying that Fnet is 0. Okay, so this is true as well. Okay, so answer is C. Okay, C3. The total weight of a gas-filled balloon is 800 Newton. So I'm going to draw a sketch. This is my balloon. So in this chapter, it is very important that sometimes you sketch your free body diagram. You sketch out all the object. Okay, then you draw all the forces acting on the object. Rather than just thinking it in your mind, it's easier for us to put it down into drawing. Okay, so we can have a better understanding of whether is there Fnet or not. The weight is 800 Newton, so I draw a downward arrow, 800 Newton. It rises at an acceleration of 1.5 meter per second square. By now, you would have be able to think of whenever there's acceleration, there's going to be Fnet. Okay, whenever there's acceleration, there's going to be Fnet. Okay, and the value of acceleration is 1.5 meter per second square, and the direction is actually upwards, right? Because it says it rises. But now here's a problem. The formula is Fnet equals to MA. we have this value of acceleration. We do not have Fnet, we do not have the mass, which means we can't solve this problem. But wait, it's really weight. This is 800 Newton, and the formula for weight is W equals to mg. Okay, so although I never specify over here, this thing is on Earth, so the G is going to be 10. The mass is unknown, but I have the weight, therefore the weight is actually 800, right? 800. So therefore, my mass is going to be 80 kg. Okay, so this question, although it's like 1 or 2 lines, but there is certain difficulty to it, because you may not be able to find what is mass if you have forgotten this formula. So now that we know our mass is 80 kg, we can substitute in. So Fnet is actually mass of 80 multiplied by 1.5. That means my Fnet is going to be 120 Newton. So how do I represent Fnet? I have to draw a double arrow without touching the object. So now I have 120 Newton that's upwards. Okay, so there must be an upward force on the balloon, of course pointing upwards. If this upward force is, example, if this upward force is 800 Newton, okay, let's not look at this over here first. If the upward force is 800 Newton, downward force of the weight is 800 Newton, there is no resultant force. Okay, but then it contradicts the story, because the story says that there's a resultant force of 120 Newton, provided you can get until this step. Okay, so what if I increase the value to 810? Then there will only be a 10 Newton upward force. So therefore, what do? I need to add this 800 Newton to this 120 Newton, and I'll get 920 Newtons. So if you consider upward force of 920 Newton, downward force of 800 Newton, then we take the larger value minus the smaller value, we get 120 Newton, and it is in the upward direction. Therefore, the upward force acting on the balloon is 920 Newton. They are not asking for resultant force, they are asking for the upward force. But we do need to find the value of the Fnet, okay, before we can determine that. Okay, maybe we'll stop at C4. Okay, C4, because C5 is quite difficult. I'll have to explain in class. Now, C4, the figure shows the variation with time of Fnet, which is acting on an object. So this is actually Fnet. Okay, and before, from 0 to time t, there is a constant Fnet. Constant Fnet. So if I have constant Fnet, which means I have constant acceleration. Constant acceleration. But what does constant acceleration means? Means the velocity is increasing at a constant rate. Okay? So I do this one more time. They are saying that this is a graph that shows the variation of Fnet acting on an object versus time. So I see from here, from 0 to t, it has a constant Fnet. Right? You can see that the value is of a certain value. Okay? So constant Fnet, then what must you think of? Oh, if there's Fnet, there must be acceleration. And because it is constant Fnet, and Fnet equals to ma, right? Mass is fixed, you don't change the mass of the body. And if my Fnet is constant, my mass is constant, therefore my acceleration must be constant. In kinematics chapter, constant acceleration, it means that the velocity is increasing at a constant rate. We'll be using this later. Then after time t, we see that the Fnet is 0, right? Suddenly it dropped down to 0. What do you think of when we say that Fnet is 0? That means acceleration is 0. So there are two cases. Is the body moving or is the body stationary? Okay, before that the body was actually moving. There is a velocity. So therefore, after this, even though the acceleration is 0, it will move with constant velocity. Okay, so I hope you still remember your kinematics concept. So which one shows the variation of its velocity with time? And actually, I think we work on this is easier. So what did I say about this? After time t, right, it must move with constant velocity. Okay, why? We work backwards. How do I get to the object moving at constant velocity? Because the acceleration is 0, right? As long as you move with constant velocity, acceleration is 0. And how do we get to acceleration is 0? It is from this F net equals to 0. How do we know F net is 0? We look at the graph, right? The graph told us that F net is 0. Therefore, acceleration is 0. So it moves with constant velocity. So straight away, A is out because it is 0 speed. Okay, 0 velocity doesn't mean constant velocity. D is also out, right? Because there is still velocity. And the velocity is decreasing. But I'm looking for constant velocity. That means I'm looking for C and B, right? Either C or B. Okay? So now that we have eliminated A and D, let's look at B and C to see which one is a better answer. Okay, is the correct answer. So then we have to look at the red color part, whereby they say that the velocity is actually increasing at a constant rate. Okay, so which one is it? Definitely is B. So answer is B. Okay, so yeah, I hope you watch this video, because after that, when we start school again, it will be easier for us to go through C5, C6, C7, and they are quite tough. I hope you can understand this concept. Okay.